Hello pilots and ground crew, welcome back to my channel again. I got myself a new multimeter, alright, and I have wanted to do a video for a while for new pilots explaining what you would use a multimeter on for your RC models and why they're, well, I say a necessity, some people won't, but I say they're a necessity to have in this hobby. Alright, so this is not a complete rundown of how to use a multimeter to wire up stuff in your house and check sockets and this and that. This is designed mostly for the RC model world. The parts of the multimeter you'll use in the RC model world, and it's for new pilots. So if you've already owned one of these for a long time, you might as well go watch something else, right? But if you're a new pilot, and also you might have been flying for years but you've just picked yourself one up and you've never used one before, there is one or two safety features you must know. Now before going anywhere else, right, I'm gonna mention the electrics in your house. Please, right, I know we're all big kids at heart, but please don't grab one of these and think, oh, let's see what my power outlet is, and you get your pins and you shove it into your socket and you just hope and pray you've got this set right. At best you'll blow your multimeter up, right? Medium best would be you'll blow all your electrics in your house, right? Blow the circuit all the way down and blow the fuse in your circuit board. If you're lucky, at worst you could actually cause a fire, right? So make sure you know what you're doing. Most of these come with pretty detailed instructions, right? This is a more basic one, this is a more advanced one, right? One thing I would say, you can pick these things up for about £5, don't, right? Yes, they will probably work, but they're not going to have much safety features built in, and they're not going to last long, and they're not going to give you an accurate reading. You want to be looking at bare minimum about £15, right, for something like this. Right, you step it up a bit. This was, I think it was £30, yeah, off Amazon. I got it in the Black Friday deals though, so I picked it up for 20. But yeah, you can pay hundreds, but for the RC model hobby, what you're going to use it for, you don't have to pay hundreds, but you really want to be looking at £15 to £20 to make sure you get a half decent one that's going to give you good accurate readings. Alright, this is a cheaper one, as I just said, right, and it looks more detailed. Oh, it's got a hell of a lot more stuff on it, must be better. Well, no, this is actually slightly more complicated to use than something like this. Right, so it's well worth paying that extra little bit to get one where the dials, right, there's less dials, shall we say. I'm trying to keep this simple, remember, before anyone starts commenting and shouting out names and stuff. There's less information, right, because the actual settings, the individual settings, cover the full amounts, if you know what I mean. So even though this looks like it's got more functions, right, this has got just as much functions and more. So like I said, this is really for the RC model industry, right, what you would use it for. And you would use it for your DC current, which is the V symbol, right, with one straight line and three little dots underneath it. I'll tell you about the top one because people will wonder. Right, the V with a wavy line next to it is your AC, which is your alternating current, which you will find in your sockets of your house. So if you're going to stick these things in the sockets of your house, make sure you've got it on AC. Make sure these connectors do not touch inside the house or you will have a problem. Right, and accidents do happen. I don't know if you can see this pin here, right? There's a little charcoal burn mark on it, right? What I was doing, I was testing a board, right, and I made a big mistake, which I'm going to tell you about in a minute. Well, it's not a mistake, I was trying to be cocky, I was trying to be lazy, right, and basically I made a mistake and I got a spark, but luckily this has got all backups in, so it didn't burn out the multimeter, and it didn't even damage the board, right? So I was lucky. Right, so yeah, so for testing stuff for your quads and stuff like that, and yeah, little circuit board, it's all little PD old, and this is bust, you see, that's why I grabbed that to show you. No little PDB. But yeah, you want it on your DC, which is your V with your straight line and your 3 little dots underneath. You won't need AC, right? Not for your models, right? You will need your continuity, which you've got 2 marks here. You'll want the one that looks like a speaker. Now with this multimeter, when I switch it over to the one that looks like a speaker, I have to select it by pressing the select button, right? And what that does is, I don't know if you'll hear that, but it's beeping anyway. Alright, just turn that off again. But yeah, they're the only 2 you'll really need, right, for starting out and stuff. Yes, someone's going to be shouting out ohms for testing the resistors and this and that, and then don't forget I'm keeping this simple for new pilots. Right, now we'll start actually with the continuity. Why would you want it? Let's assume, I'll zoom in a little bit here, hopefully not too far so you can see, because with the continuity you don't have to look at the multimeter, you're just listening for a buzz, right? Because what the continuity does, the symbol that looks like the little speaker, it sends power through the multimeter from the battery inside the multimeter, and it sends a power, right, to your black and your red connector, right? So it's got electrical charge in it. So whatever you're testing, and this is what I did, I was trying to be clever, whatever you're testing, it must not be plugged into anything if you're testing the continuity, right? No power on the board you're testing, right? Because if you're testing and it slips, right, that's when you can get a spark, which I had on there, which I've just shown you, and you get a little scorch mark. At best you get a scorch mark, at worst you can blow your board and everything. So do as I say, not as I did. But why would you use the continuity? Let's just switch it back over. Right, let's assume something's not working. So you're thinking there's a fault, there's the power from the battery to the circuits is not working on something, but you don't know what. So you take one end, and it doesn't matter in this case which one, you can put red to black, black to red, red to black, but you want to keep in your head always red to red so you don't make the mistake when you're using the volts. Alright, so I'll go red, alright, and I'm looking for a positive, which is here. And hopefully you heard that beeping. So that tells me there's a signal running straight to that, and it's not a problem. Red is going to red. And if I test another voltage, red, red, great, great. So now I know all them reds, right, there's no interference, no problems, no now. Alright. Now down here there's a little 5 volt pin. Alright, now I'm checking for where the power would come in here and run off to your different ports, your different soldering joints where you're connecting your stuff up. Alright, now you've got your 12 volt or 7 volt or 9 volt or whatever you've got coming in here, right? But this pad is a 5 volt pad, so I don't want any sound. I don't want the multimeter to beep when I connect up to this side where the battery, the power would be coming in, and if I touch the 5 volt now, nothing should happen. There you go, no sound. Right, now if it did beep, there's your warning that even though that says 5 volts, it's running straight off the battery, full battery voltage. So don't worry, if you've got a camera or something that will only take 5 volts, if you solder it to that joint, right, that solder pad, right, you'd blow your camera basically, right? But in this case you wouldn't, because when I test it there's nothing happening, right? So in other words, there's no continuity, which is good, so that's on a separate voltage, right? We still don't know if it's 5 volts, right? But there's different ways of checking that, which when you go into your voltage. But like I said, continuity, never ever have a battery plugged in on the continuity, right? Because if you slip or whatever, you'll blow it. But we do know now, that's your ground, we do know now this 5 volt pad is definitely less than battery voltage. And basically that's what the continuity button is for, right? It tells you. Now if I put it on the red again and touch this red, there's a beep. Now if there was no beep, right, I would know that from here to here, somewhere along the lines there's no signal getting through. So this actual plus port would be no good. So maybe I could join up the wires some other way or whatever, but I'd know that port is definitely not working because there'd be no beep, and there should be. Right, now how to find out if your 5 volt is a 5 volt. Now I test, just turn that off, I test all my boards. If it says 5 volts, I don't care, I'm going to check if it's 5 volts. If it says 7 volt out, I'm going to check if it's 7 volt out, just in case. Now on this meter, all I have to do is switch over to DC. Right, I'm sorted, my DC volts, that's it, I'm done. Right, that's all I have to do. However, on a meter, multimeter like this, right, I'd be looking for my DC voltage, which on here is here. Remember the V with a straight line and the 3 little dots underneath, right? And from there, you've got 220s, 200s, 250s. Always start on the highest, right? And then work your way down to get an accurate measurement. Alright, always start on the highest number, then work your way down to get an accurate measurement. Alright, just put that to one side again because we're not using that one. Now just a little test, right? I know this should be 23 volts. Alright, so this 6 cell LiPo I've got here just to show you. So I'll just move that back out the road there, move that in shot. Zoom in so you can see it a little bit better. So if I put that onto DC voltage, now this is where you have to start being careful. You don't want to start crossing wires and stuff like that and everything, or you'll get problems. Always start with your ground. Never go in with your live, right, and then your ground. Always start with your ground on anything. So we've got your ground in. I'll do it so you can see the voltage reading. There you go, 23.1, which is spot on for that LiPo, right? Because it's a big 6S LiPo, big bugger. Alright, so that's just a way, sorry I didn't explain that, that's just a way if you want to test if your LiPos, if you think there's a fault with your LiPos, that's how you do that. Right, now getting back to this 5 volt, we've left this on DC. Right, because that's what we're checking, the DC current. Now on this point you have to be a little bit more careful. We're not on continuity anymore, so we're not going to get that problem that we did have. But at the same time, when you've got power going to something, I'm not going to be able to do this because them red lights I can't even, I'll tell you what, just for a moment, I can't see a bloody thing there. I can't see where out it is, so here's a little tip for you. If you've got LEDs and you're doing this like I am, so there you go, troubleshooting live. Put a little bit of blue tack across the lights. Don't do it in guesswork. Don't ever mess about with anything electrical guesswork. Alright, I've covered up the LEDs nearly. Alright, so they're not blasting in my eyes now, so I can see better. I can see what I'm doing more. Right, and we're going to go, because that's a 5 volt, so we're going to go from black Making sure your multimeter is on DC. I know I keep saying it, but it's very important. I'm going to go from the black, right, making sure I've got a nice solid hold on it. It's not just a loose wobbly hold. And then touch the DC pad, right. Now because these are real small pads, I don't know how I'm going to get in here so you're in shot. Right. And if I'm gentle, and I'm reading there on the multimeter, it says 5.04. So now I know that that is definitely a 5-volt pad to solder onto. Please check. It seems like a long-winded waste of time, but please check all your pads on your boards. This is, like I said, this is just an old PDB board. Right, part of it busts, so don't use it anymore. But yeah, please check that all your 5-volt pads, right, are on 5 volts, right? Because if you wire something up, just because it says 5 volts, I actually had a flight control board, right, and where it said 5 bloody volts, I wired up my camera to it, which only needed 5 volts, and you've already guessed, bugger me, it blew. Right, and when I checked it afterwards with a multimeter, there was full battery voltage coming out of the 5 volts. Right, 9 times out of 10, if it says 5 volts, it will be 5 volts, but it'll be that one time, right, when you plug something in and it'll blow, right, and there's no point ringing up the company and saying, because all they'll say is, oh, you must have crossed something somewhere and caused a short, right, and you can't prove you haven't done that. So basically your board's knackered, your camera's now, well, if you're lucky your board's still okay, but your camera's going to be knackered if you've got a 5-volt camera, which is exactly what happened to me. Yeah, so I always check that my volts are, but like I say, when you're using these things, right, only continuity, never ever ever have whatever it is you're checking power going to it, never, right. When you're checking your voltage, always make sure, I've got my caps back on here, but always make sure when you're putting it on, it's not just loose and it's not sliding about and your hands are shaking and stuff because you drank too much the night before, because that'll slide over there and it'll spark and you'll get the magic. So take your time, always make sure, use 2 hands, there you go, always make sure when you put the first one on, you've got a nice, see, that was loose. Perfect example, couldn't have happened at a better time. Always make sure wherever you're putting your pins, it's a nice solid hold and it feels comfortable, and you know, I mean, I know now that is not going anywhere. I can switch hands and I know that's not going anywhere. I can feel it in the solder. Right? I'm not pushing hard, I'm pushing hard enough to keep it in place. Alright? Before you move over to your next pad to check your pads, and always go slow, take your time, make sure you're going in the right direction, not the right direction, make sure you're doing the right pad, but you're checking. And if you get a situation like that where you can't see it, don't guess, or it could slide off and you get your sparks again. Think about how to get around it, like I just did with the lights. I couldn't see, so I put some bloody blue tack over the lights. Right. There's your basics, and remember this is for new pilots and I wanted to keep it basics. Why you would use the continuity, right? And I'll say it again, never when anything's got power to it. Why you would want to use the DC and only the DC if you're checking a battery, just so that you can, yes, we all know we've got the little battery checkers, LiPo checkers for the cells and stuff like that, right? But these will give you a more accurate reading. Yes, I use LiPo checkers too. Alright. But if, let's say there's no power getting to your quad or whatever. If you do this on your battery and your battery's fine, you know straight away, right, it's not my battery. And then you can start working on your quad. Because you could always plug your balance lead into a LiPo checker and it could come out okay. Alright. You connect your multimeter to the XT60 of a LiPo, and now it could happen because the fault could be in these wires, not actually inside the main battery. So it's just another check to do. And just remember, DC for when you're checking your batteries, your boards and all this sort of stuff. Now if you want to mess about with your electrics in your house, and stuff, and you want to stick these things inside your wall sockets, alright, the first thing I'd say is there's no need unless you're a proper trained electrician. However, if you want to, please make sure you are on AC voltage, alright, but don't do it. Okay then, pilots and ground crew, I hope this helps, and I've tried to keep it as simple as I can, right? I've skipped over a few little bits, and I've sort of like repeated myself a lot on some other bits. But if there's any questions or out like that, please leave a comment, and I'll be happy to get back to you. But one thing I will say, if you've never used a multimeter in your life, the first thing I'd recommend you do, right, once you've got it, read the instructions, right, but before even turning it on, after reading the instructions, right, go watch some YouTube videos like this one, right. There is quite a few out there which are just really for multimeters and checking everything, not just your model stuff, right, and there's some pretty detailed information out. But we all know what you're going to do the first time. You're going to grab one of these things, a battery, right, and you're going to want to play with it to see if it works, right, which is fine, right. To tell you the truth, whenever I get a new multimeter, the first thing I do is get a battery. The very first thing I do is get a battery, stick it on the correct reading, which is DC, right, put the red to the plus. Whoa, we're off running here. The red to the plus, black to the minus, just to see what the voltage is coming out. There's a tip for you. If you happen to get these the wrong way around, right, on a battery, you don't have to panic. The only difference that'll happen is the voltage will come up as minus. You see, that's saying minus 1.6 volts. And if I put it the other way around, keep my hand still, now it's just coming up as 1.6 volts. Alright, so there's not really a problem if you're checking something like that. However, it's bad practice. Always concentrate. Red goes to red, black goes to black. There are actually exceptions to the rule, right, in more advanced electronical work where you want it to be the other way around and you want to get that minus signal, but that is advanced stuff, and I'm not 100% on it myself because I am not a fully trained electrician, right, make that quite clear. It's just that I've got years of experience with bloody all types of different types of multimeters. I've been using them for over bloody hell 20 odd years when there were big funny looking things. Right, 2 bits of string in a Coca-Cola can, and you set the string on for, I'm joking. No, but so be careful. These things can be dangerous, very dangerous. So don't stick them in your light socket, right, unless you're an electrician and you really know what you're doing, right. If you're getting one for your RC models, use it for your RC models. You want your DC for checking your voltages, and you want your continuity to make sure everything links up. Alright, as in if it beeps, it means there's a signal going to where it's supposed to go. If it doesn't beep, you know there's a block in the signal. And never ever ever, for about the gazillionth time, hey, what a great word, gazillionth, for about the gazillionth time, never have power going to anything that you're using continuity on. Bad idea, bad mojo. Okay then, pilots and ground crew, hope this helps some new pilots, and like I said, any questions, just leave a comment and I'll get back to you. And cheers.